Yes, stationary point. So pretty much what we call a stationary point is any point on a graph, on a curve, that has a zero gradient. So just like a car traveling and the graph to represent it, you'd say it's stationary at the point where there's no gradient. That's what it means. So the first example, essentially, find the stationary points of the function y equals 9 plus 12x minus 2x squared. How do we find the gradient of a curve? Derivative. Great. So what's the notation for this function? dy dx. Very good. Right. What's the derivative of 9? 0. Good. Derivative of 12x? 12. Good. And derivative of negative 2x squared? 4x. Good. Okay, so if we want to know when the gradient is 0, what would we do? Yes, pretty much. Yeah, it's so straightforward. You just make that equal 0. Because we're saying when the gradient is 0, the derivative is the gradient. So when that is 0, it equals 0. Yeah. Stefan?
If your
derivative, yeah.
If your derivative has a x squared, so your original function is a cube, does that mean you'll have 2 points? The square, the positive.
Possibly. Yeah, possibly. Could happen. Okay, right, and we're looking for like coordinate points. So what do you think we do next? Solve for x, yeah. Yes. So take 12 over, take the 4 over. Pretty straightforward. Once we've got x, what do we need to find? Y. What would we sub it into, the derivative or the original function?
The original function.
Very good. So y equals 9 plus 12 times 3 minus 2 times 3 squared, which is 9 plus 36 minus 3 squared is 9 times 2 is 18. So 9 and 36 make 45. Take away 18. You got 27. So the stationary point on that graph is 327. How might you also find that a different way? What kind of graph is it? Parabola. Where's
Turning point?
yeah, and how would we find a turning point in polynomial form? Complete the square. Yeah.
Same thing.
So if you want later on, you can try completing the square and see if you get the same answer, 327. Yes?
Say that was...
Okay, so this one's a bit trickier. Y equals x cubed plus ax squared plus bx plus c. That graph passes through 0, 5, right? What's that known as on the graph? What's the point 0, 5? The what? Y-intercept. Yeah, the 5 on the y-axis. And has stationary point, a stationary point at 2, 7. Right, find A, B, and C. Looking at our original function, knowing that the y-intercept is 5, what do you think c is? 5, right? When x equals 0 for the original function, c equals 5. So that one's kind of given. Right, let's rewrite our equation with what we already know, which is that c equals 5. Oops. 5. Right, we've got some y's and some x's. So what might we use to sub in?
2 and 7.
Stationary.
2 and 7, yeah. So 7, 2 cubed, plus a 2 squared, plus b times 2, plus 5. Simplifying that, we've got 8 and 4a and 2b and 5. What might we do?
Take the 5 over.
5 and the
8.
8. Yeah, let's take the 5 and the 8 over. So together they make 13. Take that on the other side. Got negative 6. So 4a plus 2b equals negative 6. So we're going to work with that later. Right, knowing that we have a stationary point at 2, 7, what's the gradient right there?
0.
0. And how do we find the gradient of a curve? Derivative. So let's derive the function. Make it equal 0.
Oh.
Why are we doing that?
Because we know that there is a stationary point here, so we know that the gradient at that point is 0.
What if we look at the last bit that we worked out? What does that mean?
Essentially what we're working towards is a simultaneous equation. So that's the first equation that we're going to use. So deriving the function, what do we get? dy dx. What's the first term? 3x squared. Right, the second term, 2ax, yep. The next term, b, yeah. And then c, do we have a c? No, c drops off, it's just a constant. Okay, we know that that equals 0 when x equals 2. Because we've got this one here. We know that at x equals 2, the gradient or the derivative equals 0. So we can sub x equals 2 in and we make it equal 0. So 3, subbing in 2. And we know that that is 0. Is everyone still following? Yeah. Simplify. 2 squared is 4 times 3 is 12. 2 times 2 is 4a plus b equals 0. Then obviously just take the 12 over the other side. We get 4a plus b equals negative 12. We've now got 2 equations we can solve simultaneously. Right? We'll write the other one underneath. Right, what 2 terms are matching? 4a and 4a. The signs are the same, so you subtract. Yeah, signs the same, subtract. So 4a minus 4a is nothing. B minus 2b is negative b. Negative 12 minus negative 6. Negative 6, so b is 6. What do we do once we have b?
Sub it in.
Sub it in, yep. We'll go for the top one because it's easiest. So b is 6, and that equals negative 12. 4a, take away 6, so we get negative 18. Divide by 4, get negative 18 on 4. And we can simplify that to 9 on 2. So we've got A, we've got B, and we've got C.
Nice.
There you go. So all you have to really do is just look at the question. I know it's kind of hard to go from the question to all that working out, but you just have to say, like, what do I know and, like, what can I possibly try? If you try enough things, you'll eventually get to something where you'll be like, oh, like simultaneous equation. That's where I'm headed. Okay? Any questions? That's pretty much all you need to know for this exercise.